So, hello everyone. Please stop talking because we're gonna have some presentation now. So basically, today we have thanks to Aaron and Private Key Meetup, we're gonna have a discussion, short presentations about cryptoeconomics, about stablecoins. Then we're gonna tell you about TripKey that uses some elements of MakerDAO, and that's why we put it together. So there's a business case, there's theory, and so on. So I give a stage to Sandra, who's going to talk about cryptoeconomics, and then we're going to have maybe a little break and a discussion, and then move into next short presentations. That's it.
Okay, I present also shortly Laurent and me. We actually traveled from Madrid to Berlin to do this meetup here, so we are really excited to be here. I hope it's interesting for you, and we know that you normally do more like something like a chat, so feel free to ask whatever you want to ask. And we keep it as short as we can, because they also told us make short presentations, really short presentations. So I will start to speak about cryptoeconomics. Well, I don't know if you heard about this topic. I'm quite sure. I mean, in Berlin, everything is really advanced in this world, isn't it? So cryptoeconomics is something like, it's a mixture of cryptography and game theory. That's why it's called economics. And it's something similar to mechanism design. So it's actually a concept to solve certain problems. So if you know proof of work, for example, is an example of cryptoeconomics because it uses cryptography to show what has happened, and it uses incentives to actually manipulate. Sounds bad, but actually to move human behavior in a certain direction. Okay. And but this topic is so big that I will just make a really short presentation about one specific model, and also how you can attack this model in a game theory way. So first of all, in the middle of, or at the heart of all blockchains, public ones, I only speak about public ones, I guess, is the consensus algorithm. And the thing is, how can we actually achieve consensus, but in a decentralized way and without having conversations really between us? So therefore, I want to make a quick game with you. Imagine you are in a castle, yeah, you and someone else. You don't know this person, and you actually have no possibility to speak with this person. But you get a possibility to become free. But only if you answer to a task with the same response as the other person will do. And the task is to find a number in this line of numbers, which is 6-digit long, and it has to be the same number than the other person will choose. So which number would you choose? You have these numbers here, and if you choose the same one, then the other person will choose
100K.
Exactly. And why this? Any idea already why this?
Because we're lazy.
Because, yeah?
Because we're lazy.
Yeah. Because this is actually, it's a concept like when you get rewarded to find the same answer as someone else, you look for characteristics which are special. So you look for something, because this is game theory, no? You think, what will the other do? So the other will also look for something special, and therefore you choose this one. And this is actually a concept which was found out by Thomas Schelling, which sadly died last year, because we need him now. We need game theory economists in this world right now. And he did this experiment in New York. He said to people, okay, you don't have the possibility to communicate, but if you meet at the same place, at the same hour, you will get a reward. And where do they meet? Yeah, that's a little bit a culture, you know. Central, yeah, maybe today it's Starbucks, who knows. But this we also apply to our crypto world to solve problems. So in the proof of work, so for example, you as a miner, even though it's a protocol, but you have to choose which block I take. No, imagine you want to be on the blockchain, and you know that if you take the block everyone else is chosen, you get actually the reward because you're on the main chain. So you can actually enter directly the next competition to find the next block. If you choose a block no one else will choose, then you're on the wrong chain. So you lose time, because then you will find out later and then you have to jump. So therefore you look also actually something for what do the others do. And when you get a block promoted, you think everyone else will validate this block, and therefore I will also validate this block, because this will be then the main chain, and I go to the next step. Yeah, so therefore we have this incentive to find the block which everyone else will choose, because your reward is you are on the main chain. But this concept we use even more to do to solve problems with on-chain applications like dApps or whatever, or actually any smart contract, who needs to know the truth of the off-chain world. This happens actually quite a lot, yeah? That we are in the blockchain world, we write smart contracts, but we need information for example, about the weather, or we need information about the price of certain things. And how can we get this truth? Of course, we use oracles. At the moment, most of them, they use centralized oracles. What is web page, sensors, experts? What's the problem with centralized oracles? The problem we all know and we hate.
One point of failure.
Yeah, exactly. It's a central point of failure and central point of control. So what we need is decentralized oracles. And therefore we can use the wisdom of the crowd, which is actually using the intelligence of all the people together. Yeah, I could now ask you, is it rainy or is it not? And you can give me the answer, and I can make the average. So this is what is maybe the truth. And there's already the problem. How can I now find out if it's the truth or not? Because people can lie. And this is where the challing coin concept actually comes into place. Because I make new examples. Imagine the question of a smart contract, or the need to know who wants the election. So I ask this, but there's a new condition. You can now say Hillary or Trump, and you know the truth is Trump. But if you say, I need to know the truth, no? So I can't ask you, tell me the truth, because I can't find out if you tell the truth or not. But I can say to you, if you say what everyone else says, you get a reward. And what will you say then? So imagine I ask you Hillary or Trump, and you get all free ice cream if you say what everyone else is saying.
Before the election, everyone said Hillary. After the election, everyone said Trump. Yeah.
No, but
Yeah?
it says who won the election.
Yeah, exactly.
In the past.
So,
Interesting when it's about predictions, right? Then it's interesting.
well, then you have to have the condition that actually the people knows the truth.
Yeah.
If they don't know the truth, that's actually a prediction market. That's another thing. But because you think what would everyone else says, you say the truth, because it's so much easier to agree on truth than on lie. Actually, we also use this in forensic when people do interviews. They ask all these questions because they know criminals that can't agree so easy on lies, but on truth it's easy to agree. Yeah? So the problem of this is, of course, this concept can be attacked. Yeah? By the bribing attack model. So how does this work? Now imagine the same game but new rules. What are the rules now? Again, I ask you, who won the election, Hillary or Trump? And it's the same rule as before. So if you say what the majority says, you get a free ice cream. But now I say, I'm an attacker, okay? And so now I say, if you say Hillary, but all the others say Trump, you get 2 ice creams. So now, what would you say then? Think about it. If you say what everyone else says, you get 1 ice cream. But if you say Hillary and everyone else says Trump, you get 2 ice creams. Or I can even say you get also an ice cream.
Say Hillary.
Exactly, because now...
Yeah, I would ask for the ingredients first before taking any ice cream.
Vegans don't count.
Okay. Well, anyway, here, because now you can win in any case if you say Hillary. Because if you say Hillary and everyone else says Hillary, I will pay you. If you say Hillary and everyone else says Hillary, you get the reward, because you did what the majority does. And this is the thing. Well, actually, I want to explain it first in how they could use it in proof of work. They could attack the proof of work consensus algorithm by this. Because what I now can do is I put a bribe on the block I want to be included in the blockchain. So now I do the same game. Yeah? I say, if you choose this block, but everyone else is choosing a different block, you get a reward. But the thing is, in the end, because everyone is thinking like you do, everyone will take this block. So in the end, we will be here. And therefore, as an attacker, I don't have to pay anyone. Because I just used game theory to reach a moment where I manipulate your behavior, and in the end, I don't have to pay. And this is what is the cost versus budget model. So if I do an attack, the cost is actually what will I have to pay if my attack is not working. And this can happen because some people actually are, they like to sell the truth, so they are not easy to manipulate. And this attack can also have communication problems. So imagine they don't know about the bribe. And then I'm actually a little bit fucked up, no? Because then I have to pay suddenly to all the people that set my block, but it wasn't the majority. So then I have to pay. And these are the costs. But the budget is zero, because as I said, if my attack is working, you all say it. So you actually get the normal reward. And this was just a really quick way of how cryptoeconomics is applied to check on consensus algorithms. And now Laurent will continue presenting the Maker stablecoin project. And there we see also some cryptoeconomics applied. And then, you do some more technical part as well. Yes?
What are you guys doing in Madrid?
I didn't say this actually. We are Ethereum Madrid. So we started in 2016. We started with the DAO hack meetup. That was the first, and we do meetups. But we don't do only meetups. We also focus a lot on education. So we started, I guess, like all you, started with passion, with just, wow, this will change the world. And now it's about creating a community and inform people that they don't only hear the word, but actually get some real input and understand the whole dynamics about it. So we do events, we do courses, we collaborate. We don't do ICOs, so this is not. So we are not promoted by anything. We just do it by ourselves. Yeah. Come to Madrid.
Just to add on what Sandra just said, Maker is one of them, but other events that we did in the past were about building blocks, or what we like to consider building blocks of the ecosystem of blockchain. And so by first doing something around the DAO hack at the time, we then move on to prediction markets, Uport with identity, prediction market was with Gnosis, and Maker, and all those topics, stablecoin, prediction market, identity, are elements that we all, whatever the projects, we all going to use them at some point in those.
Please, louder.
In those projects. So Maker is, to me, was the worst. I mean, the most difficult one I've ever looked at. And I'm really grateful to have Dennis here with us tonight, who is working with the Maker team on something very specific that he will touch upon later in the presentation. What we're going to do, Sandra and I, is give you an overview of the projects and how it works. But please know that we might make mistakes. We won't get around it, and you are encouraged to go deeper into the mechanics of the projects to grasp the whole thing, right? And we will put some references afterwards. Okay. So the idea is really to make a stable coin. So why do we want a stable coin in the first place? We can summarize the problem with those two statements. So cryptocurrencies are too volatile if, and I insist, if what you want is to use them in everyday activities like paying bills, like set up a business plan for your company, to pay your employees and so on. if you use a normal cryptocurrency, the volatility is like making 2 times a bet on this financial product. And the other reason, and this is why stablecoin, and this is for stablecoin in particular, is that in today's economy, people that are making decisions on how to, for instance, change the economic incentives or the interests on the euro or dollar, whatever, they don't have skin in the game. So whatever the decision they take, if it's bad or wrong, it doesn't matter. They all get paid at the end of the day. Where in Maker, as we're going to see, people taking decisions have skin in the game. They are financially responsible of the decision they take. So briefly, what are the properties that I would like for our stablecoin? Well, we want a low volatility, as low as possible, but we still want some fluctuations around a stable point of reference. So it's still a free-floating currency. It will be allowed to vary through time.
Stable in relation to what?
We'll see that. There is an instrument that we use as a reference point of stability. No central authority in the way decisions are taken, so this is fully decentralized. Some automated actions to prevent some individual actors to do whatever they feel like doing, and for the system to react to bad situations. And we want, as I've said, responsibility for the decision makers. And a flexible governance, so we still want people to be able to take decisions and to change some parameters in the system according to what's happening in reality. What do we need to do this? Basically, economic incentives, and this is why Sandra presented earlier something about cryptoeconomics, because this is how you design economic incentives in blockchain projects. And you also need a sounded business logic. So it needs to be attractive to investors, to users to actually use a stablecoin, to other people to take those decisions and have stake into the system to profit from it and so on. So a sound business logic and economic incentives designed the right way. Stability, what does it mean? So stability in the Maker ecosystem has everything to do with what is called SDR. SDR is an acronym for Special Drawing Rights. It's something created by the IMF, the International Monetary Fund, that is supposedly representing the global economy. So it's a basket of 5 different currencies, as you can see down here. So the dollar, euro, the RMB, the yen, and the British pound, according to those percentages, to reflect how the global economy is doing at every time. And this gets actualized, updated, every 4 years, I think, and so on. So, but this is it's not the best, but it's the actual reference point of stability Maker is using to say this is stable. Okay?
Sorry, one question. Then it's pegged to these 5, promedio of these 5 currencies.
You mean those percentages?
You know, you have, yeah.
Yeah.
Okay.
So those are the percentages for each currency in the basket.
Okay, it's like a promedio of it.
Yeah, it's like the value of SDR will be 44% defined by how the US dollar is doing, and successively for the other currency.
Could you say it in a different way that it's pegged against the SDR?
No, it's not pegged because, as you will see, SDR is
It has a bad history.
No, but it is the reference point, and then the way the DAI, which is the stable coin, will adjust to that is with something which is called the target price. So it will still fluctuate around the SDR value. It's not pegged. Okay?
Yeah, so
But it's a
not
really
like
good question.
index, for example, where you just look up the price of gold and you always adjust. This has actually a proper mechanism to do it on its own.
Let's maybe go through a mechanism and then ask more questions, because it's going to become clearer why is it not pegged.
Yeah.
Okay.
But it's pegged. It's
Yeah.
pegged? No. With a promedio.
No, but pegged would be...
One coin goes down, the promedio will go down, and the coin in general, no.
Yes, but the price of DAI is not equal to one SDR,
One, no. But
which will be pegged. So pegged would mean one DAI is equal to $1 or 1 SDR or whatever. And this is not the case. It's adjusted through economic incentives, which we're describing.
Yeah, I understand what you
So the first component of Maker to issue the actual stablecoin is a collateral asset. Right. So to give birth to DAI, the stablecoin, the first thing you need is the collateral asset. So you will need to lock something that has value, like Ether, into a smart contract, which is called a SDP, or a collateralized debt position, to be able to issue DAI, the actual stablecoin. And this can go both ways, right? So you can lock up Ether into a smart contract and issue DAI, or you can pay back the DAI to the smart contract and get your collateral back. Then comes the stable part of the stablecoin project, which is, okay, so people will generate DAI, or issue DAI, sorry, and people will pay back DAI to get their collateral back. So this will move the price of DAI anyway. There's no way or point ignoring that fact. So we have here a correspondence between SDR and DAI, which should be the objective. And we're going to move something inside this Maker ecosystem, which is called the target price, to reflect where the DAI price should go. So imagine that you have the DAI higher than the SDR price, then it should go down. So you will adjust the target price accordingly to modify economic incentives through cryptoeconomics in order to make the price of DAI going down. But nobody will ever say, you know, this is not 1 anymore, it's 0.9 worth of SDR. This should be done through economic incentives. If this doesn't work still, and we'll see a case where it is happening, we have MKR holders. So the MKR holders are the lenders of last resort. So if there is a crash or if there is something that goes horribly wrong, we have another thing here which has value as well. Right? It's MKR tokens that have previously been exchanged for Ether or whatever. And there will be an interaction with DAI. So if this goes wrong, you have another thing of value here, MKR, to be used in that particular situation.
Maybe also to have it a little bit like visualized, you can imagine if you want to stabilize one currency, you have to actually put both parts in two. Yeah? So Maker, MKR is all volatility of one currency you can imagine, and DAI is all stability. So you have like one coin, two parts. MKR is the whole volatility, and DAI is the whole stability.
Exactly.
So to visualize.
MKR will absorb the volatility of DAI.
Yeah.
And not only that, but you also...
DAI will absorb the volatility of MKR.
No, because DAI will remain stable, and the volatility of DAI can be absorbed by the MKR.
But DAI will not have a volatility if it's true what you're saying.
Exactly. If it works.
Something volatile absorbs the volatility of something that is not volatile.
No.
No.
That's when I was also confused.
But you're right.
No, MKR is getting out the volatility of DAI. So that DAI is
but
stable.
DAI is stable. Stability and volatility are opposites.
To make it stable, DAI is not stable by just we are saying now DAI is stable and DAI is stable.
So let me use an example.
Yeah, and then
An example would be small variation of the price of DAI around the SDR will be dealt with by economic incentives. Okay, but in the event of a crash, let's say the Ether goes from 250 now to 100. That would be a massive depreciation of what was used to give birth to DAI. In this event, what will absorb that volatility in DAI is MKR, which is going to be used in that specific situation. So this will be volatile as hell, but this will remain stable.
That's basically like a central government or like the Fed stepping in to bail out the dollar, right?
but
Well,
decentralized. That's the difference.
Actually, they define themselves as an autonomous monetary policy. And they are still recreating a central bank infrastructure, really, because That's the way it is. Okay, and so to come back to what Sandra was saying, you will need oracles, like a lot in this system, to feed all the information of prices, or the different prices of the currency that we are using. Okay, so why would anyone participate in this system? Why is this attractive, and to whom? And we can see three kind of persons here interested in making this working. The first one would be the user, who would buy DAI in order to pay bills and stuff like that, and want to use this as a medium of exchange, a storage of value, because it has no volatility. So I can use this as a way to pay whatever I need to pay.
And this is actually also the criticism of Bitcoin so often. I don't know if you get this too, but so many people say it's so volatile, you will never use it for your daily purchases. And we will need, at a certain point, we will need a stable coin. If we really want to create a crypto economy, we will need something stable.
How can I pay with it? I mean, who will accept it?
Well, who does Bitcoin accept today, and who did 20 years ago?
Yeah, the adoption we won't get into, because this is something specific to Maker. Maybe Dennis can.
So if I have to change it into Bitcoin, then I'm again into volatility.
No, because once you have DAI, you can use that to do whatever you feel like doing. So you change one volatile cryptocurrency for another, which is a lot less volatile or no volatile at all. The second person who might be interested in participating in this project are the people who will borrow DAI. So are the people who will issue new stable coins. And those people will need collateral assets in order to do that. And what they want is something different. They don't specifically want to use DAI as a stable coin, but they see it as a financial product in order to get exposure on another asset, to do margin trading, or in order to use the capital they have as a collateral and issue DAI according to the conditions that the Maker ecosystem can provide. And the third...
From where come these collateral assets? I don't hear so much, so...
Just come closer. Come
There's
closer.
some space
Come
on the
here.
bench. Come here.
So the
Sit here.
I go because I'm very, very interested in
Yeah.
this kind of stuff.
Our left seat is free.
Is the camera still on?
Looks like it,
Yeah. Can you let me know if it turns off?
Yeah, it's 11 minutes. Yeah.
Okay. Thank you. So the collateral assets are whatever cryptocurrency that is allowed to be used as a collateral, meaning to back the value of the DAI that will be issued.
As a token inside the network.
So for now, it's Ether, Bitcoin, DigiGolds, and I think those are the three accepted today.
So basically, if someone is rich, as an example, they put up like 1 million Ether into the collateral kind of pool, and they get, I guess, like some sort of payout, right? Like maybe a dividend, or like they earn something from putting that collateral in.
No, they actually have to pay. They actually pay a stable fee because they get a stable coin. So if you open up this CDP, you have to pay. And the longer you keep it open, you more have to pay because you can use a stable coin.
Yes, but you will use also financial
Instruments.
not instruments, but I mean this as we'll see later. But the small fluctuations around the SDR will allow you that you have money inside the system to make profits of those variations by playing by the rules. I insist, and this is the beauty of the system. By playing by the rules and by maintaining DAI stable, you will make money. And this is how you incentivize people to participate in the system. And the third type of person who might be interested in joining are the MKR holders. So they are the ones who will take decisions on some parameters of the system. For instance, to accept a new cryptocurrency as a collateral asset, or to fix the ceiling of debt that the system can manage, and so on and so forth. So there are 5 or 6 parameters that MKR holders will vote on.
You should say this could be all the same person.
Exactly, and yeah, so all this can be done by whoever wants to do it. There is no, specific title or background or academic credits that you need in order to join the system. You can do whatever part you feel like doing at the economic level you can afford, basically. This is
everyone can join here, That's really something we don't have in our current system.
If the MKR people are supposed to maybe inject something back into the system if there's a crash in Ether, like you said, how are they incentivized? Because if I'm an MKR person, I have a bunch of money, and something goes wrong, and I have to push that money back into the system. How do I get compensated for that risk, or for providing that service?
So MKR holders provide financial security to the system, or a reserve of value to the system, and in exchange for that service, they will get fees out of all the movements between collateral assets and DAI. So when people issue new DAI or remove DAI from circulation, you will have small fees that will be paid to the MKR holders.
So the MKR people are witness or note, take care of something taking care of the value, but it's regulating the network. Okay?
It's the governance body.
Yeah, the governance. No?
It's the governance body. Yeah. But a governance model joined or in addition to an economic reserve. So, yeah, they have skin in the game.
A small example. Imagine you are in the MKR DAO and you decide on a cryptocurrency which will be included, which is a really bad one. So your decision was really bad. Then DAI will not be stable anymore because of your bad decision. And then you are forced by the Cryptoeconomics to incentivize. So you will not get paid, actually, because you made a bad decision. Can you imagine this in the current banking system? So there you see the difference.
Okay, the game is with the MKR people only.
Sorry?
The people who will play this game will be the people in the MKR.
Yeah, but everyone can be.
Yeah,
That's the thing.
This of course, but I mean between the people who have DAI and people who have collateral assets, MKR.
Exactly. I mean, another way to look at this is MKR holders are some sort of board of directors, but decentralized, and there are many more than a board of directors. And if they take bad decisions, they get ripped off. So they lose all the money they put in the system. But a new system can emerge. New MKR can be issued, and this thing can start over again with new MKR holders. So it's a way to test the decisions that are being taken and adjust accordingly, but by looking at the market only. There is nobody taking a decision to take over, that kind of thing.
You lose or you don't lose and don't win anything?
No, if the system remains stable, everyone wins. If bad decision...
Make a bad decision one time, for example?
Yeah.
You will lose one time, but then you have the chance in the next.
Yes, but somebody else, because that person will have lost money. So unless he can put that same amount of money again, it's going to be someone else joining the system. We'll get a bit more into the mechanics of it, and you will see. So there are two situations: normal conditions and extreme cases. What will happen under normal conditions? You will have people, as I said, issuing DAI and removing DAI from circulation by playing with those CDPs. And you will have SDR as the reference point of stability, and the target price, right, which can be adjusted inside Maker to reflect where the price of DAI should go, up or down. So under normal operations, this is what would happen. As we've seen, whether I'm interested in borrowing DAI, so I'm interested in issuing new DAI to do something with it, whether it's to sell to other people or to use it as a financial product to do margin trading, for instance, or I'm interested in buying DAI to pay my bills. Okay, so those are the two type of behavior we're going to observe. And then two situations can occur. One is the price of DAI is above the target price, or it's below the target price. If what I want is to borrow DAI, and the price of DAI is higher than the target price, this is super good for me, because what I'm investing in, a CDP to issue DAI, has a higher value than it should be, because the DAI price is above the target price. So I know in the future it's going to go down again, but for now it's really interesting because I'm able to invest in this financial product and get more of my money, and actually more than what it would cost me to close my position. Does that make sense? Not really.
It's maybe also important to know when you open the CDP, it always looks for the target price. And if the target price is actually below, it's cheap to borrow. So that's why I open a CDP in these circumstances.
I look for the price and it's low, then
Yes.
go and open the...
But the DAI price is really high, as we see. So if I go to an exchange, DAI is really expensive to buy.
So I don't buy it. Or I'm saying I'll wait a bit longer for the price to go down.
Exactly.
So what do we have?
At this moment.
So what do we have here? We have an increase in supply and a decrease in the demand, resulting in a net effect of a decrease of the price of DAI accordingly. But pay attention that nobody took any decisions here. We're just modifying with the target price the incentives to make people behave in a certain way. And through economic incentives, they should do it. And we will get what we want, which is a decrease in the price of DAI. And the exact opposite scenario can happen as well. So if the DAI price is lower than the target price, what I'm issuing as a borrower of DAI is worth less than what I will have to pay if I close my position. So I'd rather remove the DAI I have issued so far. So I close the position because it cost me less now to close that position than in the future, because the DAI price is too low and I know it's going to go up again. On the contrary, if, as Sandra was saying, I just want to buy DAI from the market to use it, for me it's cheap, so I buy it now. It's a good moment. And as a result, we have a decrease in supply and an increase in demand, resulting in an increase of the price of DAI.
So by borrowing you mean I'm locking, let's say I'm locking a portfolio of whatever coins, and then I can issue DAI against this portfolio, but the portfolio is locked, right?
Yeah.
And then if I want to take my coins out, my Ether or Dodge or whatever, then I destroy the DAI that I issued, kind of.
Yeah, you have to raise DAI from the market, or if you have it already, it's fine.
In order to get out.
Yeah.
Yeah.
So if DAI is cheap, it's good for me to get out now because I can just buy a lot of DAI for nothing and get my portfolio back.
If
right?
you borrow, you always
Exactly.
have to look for the target price, because the CDP will always
is
be
why.
corresponding to the target price.
So you were talking about this case where the DAI price is below the target price. Super cheap for you to close your CDP now. You might not be interested in doing that, but generally speaking, this is what's going to happen. Because you take, as the gentleman was saying in the back before, you take advantage of those fluctuations around the target price all the times to do the right thing to maximize your profits, which is beneficial for the system, which is securing stability for the DAI. Does that make sense now, you see? So you take advantages of those fluctuations.
What does CDP stand for again?
Collateral debt position. It's really a
Debt position.
collateral debt position. So you are issuing debt, which is exactly the same as in today's economy.
Yeah, right.
When you issue new money, it's a debt, really. Okay, and so this is fine, but what's in it for the people that are securing the system, so the MKR holders, right? So far, we've just seen two people buying or borrowing DAI, and we've seen that there are economic interests to do so. The other thing, which is to make the system interesting for MKR holders, is that when you open a position and you issue new DAI, there is a stability fee that will start increasing. So the longer you leave a position open, the more stability fee will be accumulated into that smart contract. Which also means that when you want to close that position, the stability fee will be registered in the smart contract. And this stability, which is a small percentage of DAI in the end, will be used to buy MKR from the market and burn it. And this is where Dennis might correct me if you feel like doing so, because I know things are changing all the time. Well, not everything, but ways of doing things in Maker are changing. And this is something that might be reviewed due to the recent publication of the CEC in the US.
How you reduce the total amount of coins
Exactly.
in the market.
You're affecting the supply of money.
Okay.
The supply of MKR. And then the value of each token goes up accordingly.
Well, but if the value of each token will go up, how it is
The MKR value, not the DAI.
Not the DAI, the MKR, yeah.
But you can create more.
MKR?
Inflation,
No, you burn them directly.
No. This is deflationary because you burn them. So you remove them from circulation.
You destroy them. You put them in a smart
How you
contract
create?
without...
Yeah, it's a way to, if you want to join, please do. But
because it's a platform.
What?
Sorry. No, how you create it? What's the question? Then I forgot
Yeah, it's
something.
a
or I
bit
don't know.
difficult maybe.
We'll see how they are generated.
Okay.
Actually, they already exist. You can invest now in Maker by buying MKR tokens, right?
From the beginning, there's 1 million Maker coins, and during the system will burn. Like if DAI performs good, then the system is deflationary, so the Maker supply will decrease from this million. And if something bad happens, like a black swan effect or a flat crash, then we will create new Maker and auction them in a decentralized manner. So the supply will increase, and this increase and decrease in the total supply of Maker also is tied to the Maker price, of course. Like if there's fewer coins, each coin is priced more.
This is where the... Yes, right.
Don't have nothing to do with Ethereum.
This is built on Ethereum.
This with Ethereum.
Ethereum, yes.
Yeah.
Yeah.
It's actually existing since 3 years. No, the project.
Yeah, a little bit longer actually was.
It's right. It's not a recent.
So
it's 3 years or longer.
I have another question. I have another question. So you said that if in case of a crisis, there is. I didn't understand what are the conditions for creating and auctioning out new DAI. If it's like completely burnt. Oh, you're gonna.
Good point, because this is just what we're going to, and I'm going to ask you the question. So, what's the worst case scenario that could happen to Maker, like in general?
Ethereum goes up.
Okay, that's even worse.
Okay.
Goes down, or there is there is a massive crash in the price of one of the collateral assets, whether that's Ether, Bitcoin, Digix Gold, whatever cryptocurrency the MKR holders decided to include as a collateral, a valid collateral, to issue new DAI. So if they take a bad decisions and this kind of stuff happen, we'll see what happened to them, to the money they put themselves in the system. And the way this type of situations is resolved is like this. So suddenly, what was at the beginning the origin of the issuing of DAI has now less value than the DAI price, market price in real life. So what gave birth to DAI has less value than the DAI itself. And so we have a problem, right? Because the value of DAI does not reflect the value of the collateral that gave birth to it. And so we have to adjust. And what basically needs to be done is remove as quick as possible DAI from circulation. But we cannot do that like, I take your DAI and I take your DAI and we find. No. It has to be done in a decentralized fashion. This is what Dennis was about to explain. And this will be done by creating new MKR. So we know this has value still. we will issue more, which will dilute the value of all the outstanding MKR out there. But this has value, so the system will create new ones, buy DAI from the market to whoever wants to sell them. And with enough DAI, we can close the positions, the CDPs there, that are still open. And we can get the collateral back. And we can sell that collateral to try to compensate for the MKR value loss that was done by generating new MKRs. So the process is, we generate new tokens by the system, so nobody's doing it, but automatically. With that value, we buy back DAI from the market. We close the CDPs that were open, so the smart contract. And by paying the smart contract back, you are allowed to get the collateral back as well. So we've, in partly resolved the problem, which was taking DAI back from circulation. And then we use that collateral to compensate if we can. So if Ether still has a bit of value, for instance, we can use that to buy MKR back from the market and burn it again. So in this way, it's like the opposite effect. I know it's a bit mind-blowing. It took me some time as well to understand it. But you're diluting MKR in general by emitting new one, and then you burn them with the little bit of value that you still have here to do the opposite thing.
But most likely MKR holders will get burned to a certain extent because they carry the risk, because they are rewarded for carrying the risk. So the whole thing seems to make sense, unless of course this worst case scenario actually happens.
Yeah.
What if, sorry, just one follow-up. The collateral assets, what if you just allow digics as collateral? There you wouldn't have this 95% drop overnight risk. I would assume at least. Because it has never happened to gold, and it's not very likely that it will happen. With Ether or Bitcoin, I wouldn't be so sure about it one day. Have you thought about this, or it doesn't make sense at all for some reason?
Dennis, do you want to take that?
So the goal is to actually keep the DAI stable, and this is achieved by diversification. So we are looking for the most stable assets which are most diverse from each other. So gold will be a good example, real estate will be another good example. So it has to be liquid, it has to be fungible. But yeah, so the more assets we can get from different markets, so that if one asset class crashes, all the other assets
that's a very good point. When real estate is tokenized, for example, then you could put those tokens into the basket. Because right now, pretty much all the crypto tokens have a correlation of 0.8, 0.9 sometimes. So if they crash, almost everything crashes. But I get the point. It's great.
Yeah, but again, I mean, this is a decision that MKR holders are going to take. So if you want to include the shitcoin into the basket, you're perfectly allowed to do so. But you're going to have to assume the consequences of having included a shitcoin into the basket.
And they vote how? Just roughly.
It's called Sentinel, and it's really interesting as well as a governance model. And the way it's done is by measuring the activity that you have with your MKR tokens. So if you move them around a lot, you're considered as an active user of MKR, and therefore your token will be worth more votes. It is going to have a higher voting weight than another one who would be left over in a wallet.
I have a question. Is one of the reasons why we put you together with the Crypt Key guys is because we're actually using the Vault, which is the technology that I believe is sort of pioneered by Maker. So this is buy and burn mechanism, right?
The voting part, or
no, the buying token on the market and then burning it.
Well, this buy and burn is reserved in the stability fee payment to MKR holders specifically. Here you have more things going on because you issue new MKR first, and then you do some sort of stuff, and then you burn some of them, but not all of them. But yeah.
Okay, because I wanted to add that the business case for this sort of some of the mechanism of stabilizing the coin is our ice cream sponsor today. But I'm not sure if it's still used in Maker. Is this contract called the Vault that actually keeps this, and or whether it's no longer used? Maybe you know better.
I don't know.
The Vault, you said? No.
Maybe we just called it a Vault, but it's buy and burn mechanism basically that we implementing now. Basically taking the code from Maker and implementing it in our system.
Really, it comes down to, I'm not a developer, but it comes down to specify a smart contract where you can only send coin to, but you cannot extract or take coins back from it, right?
This smart contract will technically use oracles to then go out to the market and buy coins. I mean, basically people would be able to sell their coins for, let's say, Ether from this contract, and then the contract just burns what the contract bought, right?
Yeah, if this is the objective. But we can...
That's how it works. I mean, how does it work?
It's a double auction, so it's an open auction, but it's happening these days.
Like, it's a contract which is made as an auction, so it defines a price it wants to buy for somehow by consulting an oracle or something.
Yeah, so let me show you this.
Yeah.
Because just to recap, we've pretty much done with this. But if you want to get more details about this, let me show you what Dennis were talking about, which is the double auction. And this would be how you can you will be using MKR in the system in the case of a crash, right? So you have a debt auction and a collateral auction. This is done automatically. In the case of a crash, you create new MKR, which dilutes the supply of MKR tokens. You sell MKR to bidders automatically, because what you want is to buy DAI from it with a new token issued. With this DAI, you close the CDPs automatically again, plus the liquidation penalty, of course, and you get the collateral back. So the smart contract is handling new collateral from the CDP it has closed. You therefore liquidate the CDP, so that's done, you're done with it. And so you go now to a collateral auction with the Ether or the Bitcoins or the Digix Gold that were left in the CDP. You can, you will first sell it for money, and with what's left from the sell, the money, you will use to buy back MKR and burn it. And the DAI left over, so imagine that, you know, this was a little bit too extreme, or it closed more than it should, you will have DAI left over. And so this will go to a reverse bid mechanism in order to give the collateral back to the original owner as well. But this you should really look into the white paper to get all the dynamics right, because it's really hardcore stuff.
Okay, so
yes.
I have a question. Because I imagine that a lot of people buying cryptocurrencies are doing it because they don't trust fiat currencies.
Yes.
So why would anyone buy something that's linked to them? It's not pegged, but it's
right.
If you're following, why on earth would you have something that, if that goes, your whole hedge is done?
I can tell you why. Because if the market is going down too fast, you want to save the savings or your earnings which you made. So this is happening, for example, in a case like when the China bans ICOs, suddenly you have the entire market cooling down. So what do you do with your crypto? Do you exit in fiat? Then it's maybe very public that you deal with crypto, you don't want this, so where are you moving into? So one mechanism is you move into Bitcoin or Ether, which are the currencies which have the largest pool, but they are also very volatile. So that's a big question. What do you go with your with the gains you make by trading or investing? And so one way is to move into other cryptocurrencies which are maybe more stable because they are less traded and they have a solid business case. Like for example, I mean, I don't want to promote one, but just have an example, IX, which is a cloud, decentralized cloud solution with a high-profile team in France, which were never hyped, so they are quite stable. You can move there and wait until the waves are passing over, like we saw with the dip, the China dip, and then get in again. Or you can use Tether, which is basically the option of Tether. It's a stable coin, but it's a shitty coin because it's not really backed with real fiat currency in the background. So it's basically to save your earnings which you made without having to leave completely crypto.
It's basically a short-term use coin.
I would suggest
no, but I mean, one complementary explanation to why to choose SDR in the first place is what does stability mean? I mean, it's really hard to say something is stable if you can't use anything already existing in today's economy. And so, I mean, by no means this is the best reference point of stability, but it's the one that has the largest scale on Earth today, because it's supposedly representing the world largest economy. As we've seen, it's a basket of 5 fiat currencies. Maybe in the future, and I think Maker is also working on that, we can find a better synonym of stability.
I mean, imagine, like what we all hope, crypto will take over, and one day euro will start to get like this. Then I assume euro at one point might drop out of this basket, and for another reason, another crypto coin will enter. So right now, even though we don't like it, fiat is still ruling the world. So, but this might change, and then the SDR will change as well. Because then it might be actually stupid to use fiat, because fiat might be not stable anymore in the future. But right now, it's the most stable one.
So one last thing, if I may, because Dennis is here and he's doing something which has great potential and it's not really heard about at the moment, and it's very sexy, formal verification. And I'd like him to briefly introduce the concept, because this is, I think, something which will get more and more heard about and important for building smart contracts projects. So Dennis?
I'm from the MakerDAO team, and I'm not really into the cryptoeconomics. I have a pretty boring talk for all of you who are not developers, but first of all, let me ask, who are programmers here? So who write code? Okay, so I will talk about formal verification on the blockchain and how we apply formal methods at MakerDAO. So first of all, why formal verification at all? So first of all, we have something called unit tests, and unit tests really what it is, if you have a state space of your app, then you just pick holes in different specific states, which you run the test to and look at the outcome. So it's like with a really specific value and address you run through a test case. A better thing which we also do is fuzz testing, where you specify a sub-area of your state and just like generate randomly different tests and poke in different state spaces. And what formal verification allows you to do is make actually statements about the whole space without leaving any holes. So here there are still holes inside, and you can still get an exploit because you didn't really verify some specific state in your state space. But formal verification allows us to like close these holes. And what formal verification is all about is it's mainly about specification and verification in the development process. And then we'll talk more about like what does specification mean to us and what does verification really mean to us. And we choose to go with linear logic, and logic as a whole is a really, really old language. So it's like being studied for hundreds of years, and it's really sophisticated, and a lot of things can be expressed really neatly in logic. But usually logic expresses statements about truth. So we can ask what is truth, what is not true in some particular statement. And linear logic takes this into a logic of state and resources. So we are able to make statements about linearity and statements about security of resources and consumption of resources and consumption of states. So what we do when we do formal verification is we write like statements like this with funny symbols. And maybe you saw, like in logic, there is this thing called implication. So A implies B. For example, if it rains, then the street is wet. It's an implication which is written usually with an arrow, which implies a true statement. So if it rains, then it's true that the street is wet. In linear logic, we have additionally to this, because it's like a superset of classical logic, we have a lolly. And a lolly is kind of a promise or a linear implication. So with this, we have a promise that once we have an A, we can always get a B. The same thing here. So this is called a tensor, and the tensor is kind of like a simultaneous conjunction. So if we have an A tensor B, we know that A and B happening at the same time in a state. Like they are not separated, but at the same time, and they're both happening. And we have different conjunctions. So, but a good example about like how we can model states in logic is, for example, we have psi as a coin, which is parameterized in the owner. So this psi is owned by Alice. And we have a promise that if psi owns an Alice owns a psi, she gives her psi to Bob, which she promised with this statement. And given those two both statements, we can prove, which is this funny symbol, that Bob has a token. So we can go from this state and transition basically to this state. Or we can prove that once we have those resources, which is Alice coin and the promise that Alice gives her coin to Bob, then Bob has a coin. And with this, we can fold up more difficult state spaces and like make formal statements about state spaces with. Yeah. What we have right now is, it wasn't mentioned by you, but before DAI, because DAI is this really huge complicated concept, we have something called psi. And psi is a simplified DAI. So it's like a cut down version without a lot of features with one collateral type, which is the maker, which is the ether, which is like we just have one collateral, which is basically ether. We don't have this diversification, but this is a thing of the future. And we have modeled psi in linear logic, and basically what we do then is just write funny formulas for every action which is possible in this psi system. So for example, this is join and exit, which means that with your ETH you can buy SKR or get SKR, or you can like drop SKR and get ETH back. So it looks funny, and it's just two actions a user can make in the system.
I have a question.
Yeah?
So each possible behavior from someone that holds psi would be reflected here, mathematically.
Exactly. It's just a state transition. So it's the promise that once you reach this state where this and this and this and this holds at the same time, you're free, when you have this promise also as a resource available, to transition to this state, which is this one. So basically this is removed and this is put into the state space again. But this is just a high-level specification. It's just like to get a really deep understanding, a mathematical deep understanding of the system as a whole. So why do we do this? It's once we have done it, we can make actual formal statements and looking for proofs. So this thing actually means we have a proof, and this means we don't have a proof, so it's crossed out. And we don't have a proof of a state which is looked like this. And this statement means that the total SKR is less than some W, and some W is a SKR owned by a user. So a user can never owns more than there is SKR in the system, which is basically just a sanity check of the system. So you cannot put more collateral, you cannot have more collateral in your balance than there is total collateral in the whole system, just a sanity check. But because we have this symbol previously, and we can start a theorem prover which gives us a proof of the impossibility of this statement with our modeling, that this is never reached. So we know that this state is impossible in the state space with an actual proof. and everybody can verify because it's open. And this was the kind of like the specification part. So we specify our system in a really high level language, try to make different logical statements about it, and poke into the system. And once we have done it, we go to the formal verification part. And the formal verification is we do the same thing in linear logic again. So basically, with the whole lolly part, we're modeling the EVM inside of linear logic again, with the same models, like with the same thing which we saw previously. So we have a state which is, we have a program counter, we have a gas, and we have a stack height, and we have some code on our state space. And once we have a proof that we have this at our state, and the uppercase variables are written as they are variables, so they can abstract specific values. So PC, for example, would be a number. And once we have a proof of this, we can transition to this, which would basically just execute push 1 onto our EVM. So it just pushes a value onto our stack. This is what it's saying. But we have model of it in linear logic.
So what can you exclude with that proof from happening to the EVM?
Later. So we can actually, once we have a model of the EVM, we can make formal statements about a state. So once we have a code, we can formalize that a state on the EVM is never reached. So for example, that on stack position 1, never a value of 0 is written. And we can make a formal statement of it. And because the EVM is deterministic, we have a proof of it that it cannot happen at all.
I see.
Sorry, but are you modeling like instructions in the EVM with linear logic?
Say it again?
If you're modeling all the instructions in the EVM with linear logic.
It's basically, yeah. So we basically.
So then you can take basically a smart contract and put it in your
exactly.
Formal verification system, and then formally verify a smart contract.
Exactly this. Exactly this is what we're doing. So we have this EVM model written in linear logic. What we do then, and this is for example the push 1 instruction. What we have now is we take a code of, for example, some simple wallet, which we put into our state, and we can make simple proofs with it. So we say once we have a code and we have an initial state and we have an assumption, and assumptions would be that, for example, on storage space 1 there is some certain address written, that under those assumptions with this code and the initial state, the same code, a final state and a stop execution is written. And it really depends what you put in your code and what you put in your final states, but you can derive a formal proof of some states will always happen, never happen. It depends really on your logic, because it's kind of a superset of classical logic, so you can express really what you like. And the next step, which is actually the fun part, is once we have a specification written in linear logic and we have an implementation with, for example, a simple wallet or a multi-signature wallet, with our EVM implementation put in linear logic, we can make a B-simulation, with showing that our specification exactly implements the implementation, and the implementation exactly implements the specification. So they both behave in the same way. And we can do it also inside of this theorem prover. And the neat part of it is that it's deterministic and the proof can be generated automatically. Needs some time though. The final step though is, which is, I still don't know whether it's possible or not, but once you have the specification, to actually generate the implementation, so you don't need to write the bytecode version of the contract yourself. So currently, there are different options. So we have actually proven like really small contracts, like a simple wallet Yoichi wrote. For larger things, basically it explodes. And since the solidity output is really large and you have to control every opcode, because potentially you have to make assumptions or adjust your initial state space precisely, you have to have a really deep understanding of your implementation on the opcode level. And when you have large contracts, which Maker has, it generates a really large amount of opcodes. It's really not practical to go over it and try to understand it. What we do currently is for really small contracts, for example, a multi-signature wallet, is we try to implement it in opcode ourselves because we have a deep understanding of it. And this would basically eliminate this state. So once we have a specification, maybe it's possible to even generate the opcodes here, so you don't have to program them in Solidity or on opcode level, because this is the most time-intensive part once you have.
So the research part is about scalability in formal verification. You could say something like that? We still need to scale formal verification to be able to handle complex.
Well, even this is scalability. This, I would say, is decidability. I don't even know if it's decidable to, or like practically doable to do this implementation, but this is like the holy grail of what we try to research and do.
I see. Okay.
That's basically it. So I hope it was not too boring. If you have questions, I'm happy to answer them.
I like the background of your presentation. Apart from that, that's not a joke, sorry. So, no, I started studying actually like a few months ago TLA Plus by Leslie Lamport. That is again a language to describe formally protocols and interaction also between agents. And I guess that what they do is basically similar. They basically explore all the space of all the states that are possible in the system. Then you can put invariants, and with invariants you can check if the system is behaving correctly. And I guess it's like more or less similar, because what you're doing here basically you're describing the state change, right, in the system.
Yeah.
They are go from state 0 to state 1, state 2, and etc.
This is like, TLS Plus is like one which is similar and more established than linear logic. Maybe the most advanced on the EVM part research is KEVM. So there are a lot of papers about the K framework and KEVM on verifying smart contracts on bytecode level. And actually, the DAO hack, for example, was verified or like shown that this can catch the DAO hack. And there are some interesting papers.
You mentioned before, but I didn't get it exactly. So do you have also like at one point like an explosion of possible states in space that is impossible or difficult to do it like with current hardware?
Yeah, we aren't that far in our research to actually encounter real examples of state explosions, but state explosion is a real problem. For example, if you have large floating point operations, there a state explosion happens because
you need to check every single possible floating point in the representation.
Exactly, but maybe you can abstract it away with like your assumptions. So you say because of something happens, and
so you simplify the assumption on the value of the floating
point. Yes. I cannot talk more about this. We haven't encountered it yet, but this is a real problem which we will encounter in the future.
Interesting.
When you reach this holy grail from going from specification to implementation, don't you think it might be not usable, because then the gas prices are too high? We will not yield like smart contracts that have low gas price, because you cannot optimize for that, right? And then it might be too expensive to really use that. So one of the naive approaches would be, because it's kind of like there's a thing called Curry-Howard isomorphism, and this is really what's used behind Haskell, OCaml, and all those ML style languages, where you have a type system, and this type system you're actually is exactly corresponding to intuinistic logic, and what is generating in the background is a lambda calculus representation of the proof of your statement, which is in some cases way too big to put it on a blockchain. This is a naive approach, but maybe some optimization techniques can make overall. For example, Haskell can also be compiled down to bytecode, and not only interpreted in this other way. But yeah.
Thank you very much, Dennis.